In this video, we'll replicate Omen's Smokescreen using Unity and ShaderGraph. I've been playing a lot of Valorant lately, and it got me thinking about how some of these effects are made. They're stylish yet simple and convey a lot of information for what they are. So I wanted to recreate something from Valorant, and Omen's Smokescreens got my interest the most. They're these cool looking ominous shadow orbs. You can also switch to a shadow realm view that changes the whole look of the map. I could see the techniques used for this, and I wanted to see if I can recreate it in Unity myself. I'll be using ShaderGraph to make the shaders, so that requires a project that uses a scriptable render pipeline, so either HDRP or URP will work. I'm going to make a new project using the HDRP template, and I'm going to clean up the sample scene. I'm just deleting a few things and disabling the sky and fog volume. I'm also going to turn off these gizmos so they're out of the way. I recreated the spike plant tutorial map in Blender, so I'll import that into Unity as an FBX and create a material for it. This and other assets I made for this project are available to download on our Patreon for free. I'm using the built-in HDRP lit shader and changing the color to a light blue and upping the metallic just a bit so things are easier to see. And with that, let's start with the Shadow Realm effect. Omen's alternate view switches to a version of the map where there's no walls, so we can place his smoke screens without any obstruction. The ground becomes this cool shadowy material with these wispy flames on its edges, and other colliders in the map become this transparent red material. You'll notice the boxes are on a different object from the rest of the map, since these are going to change materials when Omen changes views. The red material can be easily made with built-in shaders. I'm using HDRP lit again, and all I'm doing is changing the surface type to transparent and the color to a reddish pink with some alpha. Now for the hard part. I'll have to create a separate mesh for the ground since we need a wall around the entire perimeter, and some of the spots are just ledges, like here and here. So hop onto Blender and select just the ground faces of the map and duplicate them to a new object. Select the outer edges and extrude them up by 1 unit. The flames are going to be made with a texture, so let's UV unwrap the walls while we're here. Pick a wall, any wall, look straight at it, and unwrap it with project from view bounds. Since this section of the wall is 3 meters long, I'm going to stretch its UVs to be the same size. Now, select the rest of the walls and make sure your first wall is your active face, and unwrap with follow active quads, edge length mode, length. You should get this really long unwrap. This is okay since we're going to be using a repeating texture anyway. I'll also unwrap this nib the same way. Now, we want to unwrap the rest of the mesh to a single point so the ground is a solid color. So just unwrap it however, scale it by 0 and move it to the bottom left. Okay, let's re-export and bring it back into Unity. ShaderGraph time. Let's create a new unlit graph. I'm using unlit since the shadow realm won't interact with light. So I'll add a sample texture 2D node and put the wall wisp texture in it. Create a new color property and change its default color to a purple. Multiply it by the texture and plug that into the master node. Let's change the preview to quad. That's better. But the top section should be transparent. That's because we haven't plugged in the alpha channel. And we also gotta change the alpha clip threshold to 0.5. We'll also enable two-sided in the master node's options. Let's save and check it out in scene. If you right click the graph to create the material, it'll automatically set it to that shader. Looking good. Let's get those flames moving. Add a tiling and offset node and plug it into the texture. Add a time node and offset and, whoa, okay, that's a little fast. And we probably want it to move only horizontally. We can slow it down by multiplying time by, say, 0.1, and we'll move it only on the x-axis by getting a combine node, plugging time into the R channel, and plugging the RG output into offset. Looks good in preview, so now if we go into scene, it's not moving. Let's enter play mode. There we go. There's kind of a lot of peaks on the walls though, right? Let's fix that by stretching out the texture by decreasing the X in tiling. It's getting there, but the flames move uniformly and only in one direction, so we're going to offset the texture by some noise. Add a gradient noise node and another tiling and offset node. We'll move time to the noise's offset and plug the noise into the combine node. You can adjust the effect by changing the time multiplier and the scale of the noise. Now if you go back into game mode, the peaks move left and right and merge and split all differently. Moving a texture by noise is essentially the same thing as moving it by time, but time is always increasing and at a steady rate. When you move by noise, different spots have different values. White spots move it by 1, dark spots don't move it at all. Gray is everything in between. Okay, the last part of this effect is going to be the ground texture, but the way we unwrapped it, we can't use the UVs to texture the ground. So what we'll do instead is unwrap it by the world's X and Z positions. Create a position node and change it to absolute world space. Split the R and B channels into the combined R and G channels. Plug that into the UV of a tiling and offset node. Make a Voronoi node and connect tiling and offset to it, and then add multiplied times to its angle offset. If you disconnect everything from the master node and plug in the Voronoi, you get this petri dish effect on the ground, even though it's not UV unwrapped. You can see the effect is smeared down on the walls, and that's because using the position node, we're projecting the Voronoi down onto the mesh. This is a useful setup for large objects using repeating textures, like terrain or water. Let's power the Voronoi to sharpen the effect, and add it to the texture 2D before multiplying color in. Plug everything back in, and set cell density to 0.2, and there you go, the shadow realm is complete. Before we move on, it's probably a good idea to organize your graph. I like to group nodes by their function. Here are all the noise and offset nodes, these are all the base effect nodes, and the rest are for ground projection. We did all that so Omen can play some smokes, so let's make a smokes. The smoke itself can be broken into two parts, the opaque sphere that obscures sight and the semi-transparent smoke that rises from it. I created these two objects in Blender. The sphere is just a sphere, and the smoke is a slightly bigger sphere that funnels open at the top. Let's start with the opaque sphere part. You can see the sphere is lighter in the middle and on its edge. This can be easily achieved with the Fresnel effect. Fresnel is a very common effect in video games that simulates the light source behind the object, basically highlighting its silhouette. So let's make a new unlit graph and add in the Fresnel effect. You can adjust the power and even multiply it to change the look. Just remember to saturate it to clamp its values between 0 and 1, and 1 minus it so the middle is lighter. The smoke also has a scrolling texture applied to it, so let's add a texture 2D with time on its offset, just like we did before. But we want the texture to scroll up, so we'll negate time. Connect the texture to a smooth step node and change the edge 2 value to a 0.5 to sharpen the texture. Seems weird to sharpen the texture in shader, but it's actually blurred for a reason. We'll get into that later. Now we can combine this with the Fresnel using a lerp node. Plug the texture into T and the Fresnel into A, and change B to 0.5. For those who don't know what lerp is, it's short for linear interpolation. So what's happening is we're basically using the texture as a mask. Dark parts of the texture are replaced with A, so our Fresnel, and white parts are replaced with B, which we set to 0.5, so gray. We're going to use another lerp to add the edge outline. Make another Fresnel, but this time with a thin highlight. We'll plug this into A and the last lerp to T. Keep B as 1. Now we can multiply this by color to finish, but we're actually going to use another lerp so we can make enemy Omen smokes, which are reddish in the center. Make two color properties and plug them into A and B. Now you can adjust these properties in the inspector and set the color of the smoke to whatever you want. Enable two-sided and go back into scene. Looks good on the outside, but if you go inside, it's a solid color. This is because of the way the Fresnel works. Even though we enable two-sided, backface normals are still pointing out, so light won't work correctly. So we need to use the isFrontFace node. This will return true for front faces and false for back faces. Connect this to a branch node so we can return -1 if it's false. And we'll multiply that by the normal vectors, so backface normals will now point in the opposite direction of its front face. Connect this to both the Fresnel's normals and you should see the effect is now applied on the inside. Remember how I said I blurred the texture on purpose? This is so I can use the same texture to make a dissolve effect. Plug the texture into another smooth step and make a new Vector 1 property. Name it Dissolve, change the mode to Slider, and give it a minimum value of -1 and a max of 1. Plug that into Edge 1 and plug that into Alpha. Change Alpha Clip to 0.5, and now, if you play with the slider, you can make the sphere dissolve and reappear. If you look at the smoke in game, you can see it slightly pulsates. We can do this by modifying the vertex positions. So we'll multiply a normal vector node by the texture, and add an object position to that. Plug all that into vertex position. Plug all that into vertex position. Plug that into Okay, switch out the sample texture 2D with the sample texture 2D LOD. Now plug it into vertex position and whoa. Multiply the normal vector by a new vector 1 property and crank that value down, real down. The pulsating is a very subtle effect. That's better. But you can see the mesh is tearing at the top and bottom, and that's because of the way the UV is unwrapped. Vertices converge at the poles of the sphere, creating disconnected triangles in the UV. And since we're displacing based off a texture, each of these points are getting a different value, which causes ripping in the mesh. So we'll mask off the top and bottom from displacing at all. Split the G channel of the object position and get the absolute values for it. This gives us a vertical gradient of 0 to 2.5, since the sphere's radius is 2.5. Divide that by the radius to get the normalized gradient of 0 to 1. 1 minus it so we can multiply the normal displacement at the top and bottom by 0. Now the tearing should be gone. For the semi-transparent smoke, we'll make a new unlit graph and change its surface type to transparent. It's going to be fairly similar to the base Smokescreen shader, so go back to that and copy the scrolling texture and displacement mask. We're actually going to use the displacement mask to fade out the smoke at the top of the funnel. Divide it by 4.5 instead, since that's the height to the funnel, and multiply that by the texture. Multiply it again by a vector 1 property with a range of 0 to 1, so we can fade the entire thing in and out. All this is going into alpha, so create a color property and plug it into color. Easy. Since I'm lazy, I'm reusing the Smokescreen shader for the skybox. I grabbed the smoke sphere, duplicated it, and scaled it up by 100. Seems kinda hacky, but that's exactly how Valorant does it. Create a new HDRP unlit material. Set it to transparent, blending mode to alpha, put in Unity's default particle texture, and change the color to a bright blue. Make a particle system and set its material to your new material. For its settings, I'm going to set lifetime to 5 to 10, speed to 0, size to 1 to 5, emission to 50, shape to sphere, radius to 125, thickness to 0.1, orbital Y velocity over lifetime to -0.2, size over lifetime to this, and noise frequency to 0.1. What's left? Let's quickly make an indicator. This will use the smoke sphere mesh, but only the edges are visible, so we can plug in a Fresnel effect into transparency. Don't forget to change surface type to transparent and turn on two-sided. Copy and paste in our back face normal flipping nodes, add in a color property, and it's looking pretty good. But it also needs an outline where it clips into other objects. So grab the scene depth and screen position nodes, change this to I and this to raw, and subtract screen position's A channel with scene depth. Saturate and 1 minus that and add it to the Fresnel. The clip-in outline is looking a little thick, so let's create a vector 1 property and subtract it from screen position, and subtract that with scene depth. Now we can control the thickness in the inspector. I created sprite sheets for the screen white when you switch views and for when the smoke spawns. They're PNGs just like textures, except we have to change some import settings. Change texture type to sprite, sprite mode to multiple, and mesh type to full rect. Apply those settings and enter the sprite editor. There's a few ways you could slice your sprite sheet. In this case, I'll use grid by cell count. Here I have 5 columns and 4 rows, so I'll enter those numbers in and there you go. Click apply, and when you expand, you can see all the individual frames. We'll make this screen wipe animation by adding a UI canvas to the scene and adding an image to the canvas. I'll set the anchors to stretch on both sides and zero out its values. Open up the animation window, and with the canvas image selected, click create and save a new animation clip. Select all the frames and drag them into the timeline, and you just made a sprite sheet animation. Easy. Alright, we have all the components to create Omen smokes. Last thing for us to do is to animate the smoke spawning in, staying in for its duration, and disappearing. So, let's select our smokescreen object and create a new animation clip through the animation window. I already sliced up the spawning sprites, so I'll drag those in first. The smoke doesn't actually appear until the sprite animation ends, so we'll add the dissolve properties of the sphere and smoke and keyframe them to appear when they should. I'm also scaling the sphere so it looks like it expands from the center. Add another keyframe in the middle that goes past its normal size to get that bounce. Omen's smokes last about 10 seconds, so we'll keyframe it to disappear then. This time, I'm scaling the sphere only on its X and Z axis to give it that dissipating into air feel. And there you go, you have all the parts to Omen's smokescreen. All that's left is scripting them to work together, but this was a lot of legwork already, so we'll cover that in part 2. If you enjoyed this video, please check out our other tutorials, and subscribe to know when part 2 comes out. All the assets used for this project are available on our Patreon for free, so check that out too. Thanks for watching!